Example number 7 is called a method of bisection, so our bisection method. And here's what they want us to find. They want us to find a solution to the following. So they want us to find a solution to this equation on the interval from 0 to 2, okay? And they want it to be within an accuracy of 0.1. Okay, so here's how we're going to do that. It's nice to draw out a picture of this guy. You don't have to know exactly what the function looks like. So here's what we're going to do. We know 0 and 2 are our endpoints. Okay, so that's these two guys. We're going to look at all the values in between. That's where we're going to find. We're going to try to find our solution to this equation equals 3. Now what we do know is that the endpoints f at 0, okay, would be 0 minus 0. So I'm going to define, this is really from the last, oops, there's one too many pieces in the define there. Let's define a function f that's equal to x to the 5th minus x. And we want to show that at some point there's some x value in here that is equal to 3 out. Okay? We know f of 0 is 0 minus 0, 0 minus 0, which is 0. We also know f at 2 is 32 minus 2, which is 30. So our function is at 0 here, it's at 30 up here. We also know it's continuous, and our quest here is to find where it crosses this line, because that's essentially what the solution to this equation is. Okay, so we want to figure out where does the graph cross. And we don't need to know what the graph looks like. What we're going to do, the bisection method asks us to split this interval in half. So there's 1. And what we do is we test f of 1. So we plug in 1 and we get 1 to the 5th minus 1. Wait, that's also 0. We did that last problem. Okay, so we know that this guy and this guy right here, okay, have to contain, this interval right here contains the value 3. Not necessarily this interval. Now this interval could contain it. It could be possible that it jumps up and down a bunch here, but I know for sure that the interval from 1 to 2 contains it. So now we're going to look, now we're going to look at the interval from 1 to 2. And so we've got f at 1 being 0 and f at 2 being 30, so we're going to split it again. And now we're going to grab 1.5. And what we're going to do is we're going to test 1.5 to see it's above or below 3. So, oops, I'm going to close these guys out. Grab a calculator here. Okay. So because 1.5 to the 5th is not an easy value to compute, okay? So what I'm going to grab is f at 1.5. Well, that would be 1.5 raised to the 5th minus 1.5. So that gives me we'll say 6.1 approximately. Well, 6.1, well, that's up here somewhere. So now I know that my 0 falls, the solution to this guy falls somewhere in here. So now we'll split this guy in half again. So now our interval that we're looking on is from 1 to 1.5. And we know f at 1 is 0, f at 1.5 is approximately 6.1. And so we'll split this guy in half and we'll grab this guy right here. Okay, so now we're going to test the average of these two, okay, which will be f at 1.25. So let's go back here and let's take 1.25 and let's raise that to the fifth, and then let's subtract off 1.25. We get 1.8. So now we're below the line here at 1.8. So now we know it must exist between 1.25 and 1.5. So now our interval is 1.25. This is not a fast technique, okay? There's faster ones out there, but this is the bisection method. It works all right, okay? So now we'll test this interval, and we'll take half of that. So half of that, 1.5 plus 1.25, divide that by 2, 1.375. Okay, so we want to test what is f at 1.375. So we take 1.375, raise it to the fifth, and then subtract off 1.375. No, I did that not right. Hang on one second. So let's try that again. So I had 1.375 raised to the fifth power, and then we're going to subtract 1.375. We get 3.53. So that's above, okay? So now, since it's above, okay, up here somewhere, we're looking for the interval between this guy and this guy. So we're looking at the interval 1.25 to 1.375. Now the question is when do we stop? Well, we stop when these guys are within 0.1 of one another. Okay. So, or at least I guess when we're within, let's see here. Well, yeah, we want to be within, they want us within 0.1 of the value. Okay. So we know it falls somewhere in here, so let's take the average of that. So we've got 1.25, and we're going to add to it 1.375, divide that by 2. And that gives us 1.3125. So we're going to test, what was it again? 1.3125. Now, once we're here, okay, we're essentially within our x values. Okay, so our interval looks like this: 1.25 to 1.375. We know that it falls somewhere in here. Okay, now I don't know exactly where it falls in there, but it's somewhere in between there. So if I take and I test 1.3125, okay, so at 1.3125 to the fifth minus 1.3125, that gives me 2.58, which is just below. So 2.58. Let's make sure I got that in there. Okay. Now these guys right here, I'm within one value of the two of the value 3, okay? But I'm not within 0.1 of those, okay? So this guy, since it fell below on the left side of it, means here's 1.3125. It means it falls somewhere in here. And now that's the key. Since it falls somewhere on this interval, we're at 1.3. Okay, now We don't know whether it's point whatever after that, but we know that 1.3, that value right there, is in between there. Okay, between here and here, we're within 0.1 of where our x naught should fall. So we don't know if we take 1.3, which falls just outside of it. Okay, if we take that, we don't know exactly how far up and down we're going to fall, but we know our x value is 1.3. It's going to be 1.3 something. We just don't know what that something is. But this part of it we've already guaranteed ourselves. So in fact, if I go ahead and I try to solve this, watch. Let's go ahead and ask, we'll grab a calculator. Okay, so we've got our calculator, and if we ask it to solve when those guys are equal to one another, we could do it like this. We could go x raised to the fifth minus x. We want to know when is that equal to 3. So this is the guy we're looking for right here. So we'll use this to find the intersection. And on the left side, this guy, and there it is, 1.341. So we got there by bisecting it, just going back and forth until we wiggled our way into a certain range, and we knew the x value that solved this equation was in that boundary range.